Hello. So in one of my videos, I gave a brief history of physics up through the Perseverance rover on Mars, and I tried to make the connection between, physics, specifically the conservation of angular momentum and the rover, how to get them over to reach Mars. I wanted to talk more in detail about that. So it's really cool here. So angular momentum is basically why gyroscopes don't tip over, or a tops doesn't tip over, or anything spinning doesn't tip over. It's really cool. Let's talk Newton sort of. This comes from Newton's physics. Let's talk about the planets orbiting about the sun. Many people that think they orbit the sun in circles, they actually orbit the sun in like a football shape or an egg shape, a squish circle, that's called an ellipse. Some of the ellipses are very much like a circle. Like the orbit of the Earth is almost a perfect circle. Let's talk about Mars. So Kepler was studying Mars's orbit, and it's pretty cool that we're sending Perseverance to Mars, because it was when Kepler was analyzing Mars's orbit around the sun that he realized it was an ellipse rather than a circle. That's right, an ellipse rather than a circle. It's almost a circle, but not quite. If he had chosen maybe any other planet to deal with other than Mars, he might not have made that discovery. So it's fortunate for us that he happened to study Mars. Now, basically, the farther a planet is from the sun, the more what's called angular momentum it has, I think. Which basically means its ellipse is bigger. So, what scientists do when they figure out an angular momentum is related to the energy of an orbit. So when scientists are figuring out how to send like Perseverance to Mars, they have to figure out like how much energy to give that rover vehicle, that the rocket or whatever, and when to launch it. Notice that it basically took half a year, 6 months, I think, for the Mars rover to get to Mars, and that's basically because you launch them when they're opposite. It's easier to show this on paper, but opposite sides of their orbit. And if you study ellipses, which I recommend that you do, you have what's called a semi-major axis and a semi-minor axis, and the scientists can calculate what those are and what they need. So yeah, it's all pretty cool. My advice to you is to study math and physics. If you like, cool stuff like sending stuff to Mars, and try to understand the facts in math and physics. Don't just accept them on faith. Don't just accept without trying to understand it, what your teacher's telling you. All right, it's bye for now. I'll see you in another video. Goodbye.